So hello everyone, my name is Pritam Paul and welcome to another video of the tree playlist. In this video, we are going to talk about the operations in AVL tree. Okay, so there are basically three operations in an AVL tree. First one is searching, another one is insertion, and another one is deletion. Let's talk about the searching first. The searching is absolutely same process of binary search tree. We have talked about binary search tree and also its searching operation, how you have to search in binary search tree, correct? The insertion deletion also I have talked about, and insertion and deletion also almost same, but here as we are talking about the balance factors, okay, so we have to take care of that also, and there are some little bit twisting would be there. Okay, so before, like, that's why I am not now I am not discussing about searching, okay, because it's almost like absolutely same, not almost, absolutely same. Go and watch that video if you haven't watched it, if you are new to the channel also. And guys, if you are new or if you haven't subscribed the channel, please do hit the subscribe button, because it really motivates me to make more and more this kind of videos. If you really found these videos useful, please do share these videos with your friends as well. Okay, so before starting the insertion and deletion, you need to know few things. You need to know what is called rotation. Okay, I have told you guys in the previous video here that if you want to convert this kind of unbalanced tree to this kind of balanced tree, we need to use rotation. I told you guys that I will be talking about it later. So this is the time to talk about rotation. Now, what is rotation? Okay, rotation means here we will talk about tree rotation. Okay, so after insertion or deletion operations, the balance factor of the nodes are affected and the tree might become unbalanced. For example, okay, so here this is the thing. Now the balance factor would be what? It would be 1, 2 minus 1, it would be 0, it would be 1, it would be 0. Now if we insert 1, obviously it is going to insert it here, then the balance factors would be 0, here it would be 1, here it would be 2, and here it would be 3 minus 1 is 2, and here it would be 0. So in this way we can see that the balance factors have been changed. These are the new balance factors, right? So obviously the tree has become unbalanced, correct? So we need to rotate the tree in such a way, either this direction or this direction, in such a way that it could be a converted into a balanced, okay, balanced binary search tree or AVL tree. It's an unbalanced unbalanced tree right now, and we have to make it balance. This is the purpose of AVL tree actually. Our AVL tree is nothing but like by these rotations in AVL trees, you need to convert like unbalanced to balance. That's it. Okay, so as I have here drawn like this and this, so this means what? Right side rotation, and this means what? Left side rotation. That means like we have actually two kinds of rotation. The first one is right rotation, another one is left rotation. There are two rotations actually, right rotation and left rotation. So like rotations are simple manipulation of pointers which converts the tree in such a way that the new converted trees retains the binary search tree property also, with in order traversal same as the original one, but it would be balanced. Like the in order, like we know that in case of BST, the in order traversal is what? The increasing order The increasing order of the numbers, isn't it? Like here it would be like 1, 2, 10, 15, and 20 in such a way, right? So this will remain constant after rotation as well. The in-order traversal would be a constant, like it won't be changing. Obviously, if it is getting changed, then it won't be a binary search tree anymore, right? Then balanced binary search tree, how it could be? Correct. So the in-order traversal would be same, the rotation has to be done in such a way, and how, when, on which node you have to rotate, that the thing you need to understand the rotation concept first, and after that you will get to know that what to do. Your instincts will tell you, and obviously there are procedures, so by those procedures also, by the instinct also, you will get to know that how the rotation would be done, in on which node it would be done. That's all. Okay, so now let's see how the right rotation and left rotation are performed in binary search trees. Okay, so let's start by right rotation. Okay, now for example, I am not describing anything in details, like in a laborious way. I am trying to make it simple so that you would understand it. Okay, so p a, and here it would be, so here it is a of l left subtree, here it is a of r right subtree, here it is p of r, like p of, like right subtree of p. Okay, for example, we are doing the right rotation here on p. This is the symbol of right rotation. So after that, what will happen? The tree will be like this. Okay, so this is the ultimate tree. Okay, this is the resultant tree. Now how it has come, so you can see after right rotation, obviously this thing, like when you will be twisting it like this, then obviously a will be shifted to here. Okay, and a of left will be like this. Okay, but p would be the right of the right node of the right child of the a. But what would happen with this? It would be associated with it. Why? Because after all these things, who is the successor in case of in-order traversal? P, right? Then this a would be heading to this, because after clearing all these things, you will be coming into this subtree, and then p, and then r. Here also, like after all this happening, like let me explain, let me write it down. The in-order traversal of this one would be what? A of l. Okay, then a, then a of r, then p, and then pr, isn't it? This is the in-order traversal of this. And what would be this one's in-order traversal? This is going to be what? This is going to be obviously a of l, then a, then a of r, then p, then p of r, isn't it? So you can see all the similars: a of l, a of l, a, a, ar, ar, p, p, pr, pr. So the in-order traversal of both the trees are same, but here we have done the like rotation, isn't it? This rotation actually is happening. So you would be asking me like, where sorry, why the rotation is very necessary for all these things? We will talk about it later. For now, just leave everything and try to understand what exactly right rotation is. Okay, so we, the ultimate aim is to remain same. Okay, to make it same, like to make it remain same, like the in-order traversal. Okay, so this in-order traversal and this in-order traversal are same, but the tree structures are not same. So by this kind of manipulation, okay, that's why I told you that rotations are nothing like simple manipulation of pointers which convert the tree in such a way that the new converted tree remains the same binary search tree property also, with its in-order traversal same as the original one. Okay, so this is right rotation. I hope it is clear. Okay, if you tell me about the process, like if you talk about the process, then let me write it down. The changes that takes place. Okay, the changes that take place what are the changes will happen? First one would be right subtree of A becomes the left subtree of P. You can also say that like these are the formula or the like procedure, you can say right subtree of A would become left subtree of P. Okay, P becomes the right child of A. And number 3, A becomes a new root of the tree, of that tree or subtree, because like every time we will not be performing the rotations on root only, right? This could be here also. Okay, so we will talk about it with an example, don't worry. Okay, so okay, so this is the right rotation. If I give an example, okay, let me give an example to you guys. For example, 50, 25, 15, 4, 6, 18, 30, 60, 70, 65. So what is the problem here? So this is having -1, this is having 0, 0, 0, 0, this is 1, this is having what, -2, and here it is 1, 2, 3, 1, obviously it is 2, it is like 2 minus 1, 1, and here it is 1, 2, 3, 4, and this is, so obviously it is an not balanced. Okay, so what are the nodes, okay, which are not balanced? First one is this one here, correct? Second one is this one. So we can do what, like we can do the right rotation here and we can do the left rotation here. Now why here it is right rotation and here it is left rotation? Left rotation I will not talk about right now. Okay, we will talk about it later. First talk about the right rotation. Okay, so why it is like happening, like why it is like right rotation here, we need to talk about that. And how will you decide like the right rotation here is needed? You can see the this one, this balance factor actually. Okay, this balance factor will tell you that yes, the right rotation is needed. Why right rotation is needed? Because in the left side the number of nodes are higher, right? That's why the height is higher, that's why it is positive. Okay, so we can say that like if the balance factor, okay, is greater than 0 or positive, we can do right rotation. Okay, right rotation, why? Because in the right side there are less nodes, right? So after we have to move it into the right side so that the right side also could have more paths or more nodes, so that the balancing would be there. Okay, this is why you need to understand the right, why the right rotation. Now if I do the right rotation, what will happen? You need to understand that what I have told, that the left subtree of A, okay, what I have told that the right subtree of A would become the left subtree of P. So now who is the P here? This is the P and this is the A, isn't it? This is the P here and this is the A. Okay, so the right subtree of A would become the left subtree of P, that means this 18, isn't it? So obviously everything will be remaining same here, 50 and 60 and then 70 and then 65, this part is same, but here it is 25, sorry, it won't be 25 right now. Okay, what it would be? It would be 15, because the A becomes the new root of the tree of, that's why I have written here subtree. Okay, in this subtree this is the root node, right? Then the A will become the new root node 15. Okay, and then obviously it will be shifting to 25, and then 30, and this 18 would become the left subtree of 25. Okay, so 18, and then it would be 4 and it would be 6. Now if you compute the balance factor, then obviously what will happen? Obviously it is 0 0 0, it is -1, it is 0, and it is 0. Okay, so see how the balancing has done. Here it is 2, here it is 2, and it is 0, but in this case here it was 3 and it is 1, and this was coming 2 only. Correct? That's why the right rotation is happening. After the right rotation, see the balancing is done. And here in the same way it is, if with the left rotation, we will talk about it right now after a few minutes. After that you will get to know that how the left rotation is working, and this part also will be balanced. Don't worry about that. Okay, so in this way actually right rotation happens. Okay, now let's talk about the left rotation. Now in case of left rotation, what will happen? For example, it is P, it is P, sorry, it will be PL, here it is A, and it is AL and AR. Okay, now if I do the left rotation here on P, what will happen? The A will become the root, P will be coming into the left side, it will be coming like this PL, and this AL would become the right side of, just the reverse one, right side of P, and here it would be the AR, obviously. So in this way left rotation would be done. Okay, now if I do the left rotation here, okay, so let me copy this. So here if I do the left rotation like this, then what will happen? So by the left rotation, what will happen? As there is no node here as P or something, okay, as you guys can see, obviously this 60 would be shifting in this direction, and then the 70 would be taking over there, and 65 would be the right of the 70. This is all these things are going to happen. Okay, so let me one second. Okay, so let me draw the tree and we will understand. Okay, so this part is done by the right rotation, right? So I am putting the right rotation version here as well. Okay, Achha, leave it. We will be copying this part, and we will be trying to, like, okay, that's fine, we will be doing it later. Okay, so now what will happen here, that this will be 70, this is going to be 60, and this is going to be 65. Okay, so in this way, like how the balancing is done now, 0 0 0, and it is coming 4 minus 2, obviously it is going to be 2. Okay, so these are the things. Now like left rotation is done, right rotation also. Now let's talk about the both the like, this is the left rotation first of all. Okay, now we have done the right rotation as well. Now let's do both and try to understand like how the things will happen. Okay, so let's go back to the previous example for sure. So for example, it is, so obviously the balance factors would be 0 0 0 0 1 minus 2, and here it would be -1, here it would be 1, and here it would be 2, and here it would be 4 minus 3 is 1. Now after the left sorry, after the right rotation, what will happen? We have seen that. And also the left rotation, what will happen? We have seen that. So we are going to directly put the thing like 50 65. Correct? Now if I do the thing like 0 0 0 0 0, and here it is 1. Okay, here it is 1, here it is 0, here it is 0, here it is 0, and here it is 3 minus 2 is 1. See, so after the left rotation, okay, after the left rotation we have found out that this is not sorted. After the right rotation we have found that this is not sorted, and also this is 4 minus 2, so this is also coming to, this is also unstable. So you need to do in such a way that left right, like wherever the nodes are initially you found out that these are not stable, you have to do it for those nodes. Like here I have done for this and this, because initially I found that 2 and minus 2 here, so that's why the like in the respected nodes, like we have to do the rotations, like necessary rotations. Okay, after doing both the rotations you can see all these are balanced. Like this is an AVL tree. Okay, this is an AVL tree, we can say, or balanced binary search tree. Okay, so in these way rotations are needed. Okay, I hope you understand the process. If you haven't understood, like another thing is like okay, and if BF is okay, if the balance factor is less than 0, then blindly you have to do it left rotation. Okay, and I am not writing the left rotation processes, it's like just the opposite one of the right rotation. You just write it down, or if you like write it down and get to know. Okay, so in this way, like you have to do it. Okay, I hope you understood, and if you have any kind of doubt, please let me know in the comment section. I will make another video for it if you like having any, particularly if you are facing any problem. And please do hit the like button if you really found this video useful, and hit the subscribe button if you haven't subscribed to my channel. And this much for today guys, and see you in the next video.